All right, good morning, everyone. It's about 10 o'clock, so I'll go ahead and get started. Anyway, my name is Caitlin Williams, and I am a geotechnical support analyst with Petrosys. And this morning we're going to be talking about handling unconformities and mapping subcrops using Petrosys. All right, so we're going to be using our grid arithmetic this morning. And so I'm going to go through talking a little bit about the theory of the grid arithmetic, how we can use it with grids. And then I'm going to demonstrate or talk a little bit about first how to use the grid arithmetic to solve unconformity problems. And then I'm going to do a demo to show you how to use this grid arithmetic module, all the other options you have when you use it, and then I'll have a brief summary there at the end. So what is grid arithmetic? It is a tool in our service modeling module that can be used to perform grid operations. It can perform mathematical operations, geometric. You can use it to clip grids or merge your grids, as well as doing conditional testing. And what I mean by that is if-then statements or else-if statements. This module uses existing grids, so grids that you've already made using Petrosys or .gri files. It also can use constants, which I'll demonstrate, as well as XY coordinates or lists. Your input grids in this module can all have different geometries, but as you'll see when you go to define your output grid, you'll define a whole new output geometry there. So this is what the module looks like. You have the option to enter formulas manually, which can be effective if you are trying to do something a little bit different with your grids. However, Petrosys also comes with a number of predefined templates, and there's a lot to choose from, and we'll go through those briefly during the demo. So for this particular demonstration, we're going to be using the subcrop formula. It comes already, it's already an option in Petrosys, and this particular formula has three variables that we're going to be using today. The subcrop is our output grid file, so we'll be naming that and saving that in our Petrosys project directory. We've got the deeper grid, and this is the grid that is intersected by an unconformity, as well as then we're going to have our unconformity surface. And so we'll specify all of these three variables and be able to run our grid arithmetic using that. So what the subcrop is going to do, this formula works by comparing the value of the deeper grid and then the value of the unconformity surface at every grid node. And then it's going to take the maximum value of these two and use this value in the new subcrop grid or the new merged grid. And you can see here we've got a little cartoon showing you how exactly this is going to work. So you can see the deeper grid coming in. It's going to compare those two values and then use the greater one when making our subcrop grid. And it'll show up easier in the demo. I've got it all colored out, so we'll be able to see it a little bit better. All right, so I'm going to run our demonstration. I'm going to be running this using Petrosys version 17.7.2. So I'm just using a test project that we've made for our training data. And just to show you quickly what we're going to be doing, I'm launching that 3D viewer, which some of you may or may not have used in the past. And I'm going to go ahead and open. This is just something I made yesterday that's going to show you kind of what our end result is going to be. Or I guess this is what we're starting with, my apologies. So here in red, you can see we've got, that is our subcrop grid. And this surface that we're working with that's multicolored, I've called this grid H. And it is our unconformity surface. So what we're going to, our end result then is to take this red grid we have here and merge it with our unconformity surface. And we'll talk about why we want to do that after the demo. So to get started, I'm going to go ahead and close that out. To get started, I'm going to open up our surface modeling module. And to run this grid arithmetic, you want to go to Grid, Processes, Grid Arithmetic. And here you can see all the different options that was in the screen grab in my PowerPoint presentation. But I'm going to go ahead and clear this out. So when you first open this, this is what it's going to look like. Your formula area may or may not be empty. You have the option to clear it out. And you'll want to insert a template. Again, here are the templates that I talked about a little bit, and you've got quite a few different templates in here to choose from. We could have, if this wasn't a particular demo, we could do math functions. There's depth conversion, simple arithmetic, that's just add, multiply, subtract, divide your grid. But for this particular option, we're going to use the geoscience examples, and we're going to use the subcrop option. And we're going to do sub C positive. I'm sorry, so we'll be picking that formula. And then when you have your formula chosen, if you want to, when you want to define your variables, you're going to hit this blue button there, and that will then bring your variables down here that you can define. I'm going to go ahead and cancel out of this, mostly because I saved a task for us yesterday. So let me get into that. So I've just made a task, and I've named it that we're going to merge our top surface with the unconformity, and I'm going to open this up. To name the task, we have an option here in Petrasys if you right mouse click to rename your task, and that's good if you want to help keep things organized and remember what you're doing, because here we're going to be doing 2 grid processes arithmetic, and it's good to kind of keep yourself in line and know what you're doing. But I'm going to open this up just by double clicking. You can see I've got the subcrop formula again. I've populated our variables. My subcrop is the output, as you can see here, and I've named it the top J formation merged. I've got the deeper grid that we've already had is just another formation I've been working with, the top J formation, and then I've specified that H grid as our unconformity. Here in the output geometry, I haven't taken the time to define any specific output geometry, but you see here that it's letting me know that the geometry from the formula's first input grid will be used, and I'm fine with that. I'm not going to change that at all. However, I do want to use contouring in this particular option, so I'm going to click Use Contouring. I've specified an output contour file. I've listed the number of grid refinements. I've left the contour up to false option on, and then I've also decided that I would like it to contour in increments of 10. I'm going to click OK. I'm going to make sure that's highlighted, and I'm going to run the highlighted task. It's telling me it's going to overwrite some files. That's fine. All right, so we know that our task is completed. Now I can get here, get in back to our 3D viewer. And I have already, I'm going to go to File, Open. I've saved what this looks like. All right, so if you'll remember, this is what we started with. We've got the unconformity surface and a grid that's intersecting it. But after we've run the task, you can see now that our grid that has intersected that unconformity surface, now we've merged it into one grid. So there's no discontinuities or gaps in here, so I think that looks pretty good. All right, so now we also want to merge a dipping surface. So I'm going to go back to our surface modeling module. Let me minimize that quick. And I'm going to open up the second task I have here, and this merges a base surface with our unconformity. So let's just open this up. All right, again, I'm using that subcrop formula, and I've named the subcrop. We're working with a different formation here, so I've specified that in our output. And I've specified that for input, but we're still using that unconformity surface there. So I've specified that down at the bottom. Again, our output geometry is going to use the geometry from the formula's first input grid, and I'm fine with that. And I left the contouring on then for this option as well. Click OK, And again, I want it to run the highlighted task. Click OK. All right, and we see that our task has successfully completed there. Let's get that 3D viewer back up. All right, so the other surface we were working with, oh, let's cancel that. We're going to display this. So we were working with, let me find this here. The base J formation. So this was our dipping plane that we also wanted to incorporate into our merged grid. And then once we have merged that, so after we ran the job, I can either go File or Display Grid, or I prefer to use this little button right here. We can find that base J merged that I made, and I'll just leave it red so we can see the difference. Click OK, and you can see then how the dipping plane is now merged with our grid and our unconformity surface. And from here, we would be ready to run volumetrics. All right, so I can exit out of this. And we're not going to save changes. All right. So as I mentioned, one of the benefits of doing this grid merging is it can benefit your volumetrics. So really doing this grid arithmetic is kind of a small but important step in a bigger workflow. So in this particular project, I had these grids. My end result was I wanted to run volumetrics or do a net pay calculation. And doing this grid arithmetic, this is going to help fix any holes in your grids and also decrease the likelihood for false volumes, which we know is pretty important when you're trying to give results. You want to make sure that your volume calculations are as accurate as possible. So just to recap, so we talked a little bit about the grid arithmetic theory. This again allows users to perform mathematical operations to their grids. Anything from basic arithmetic to more complicated if-then statements or conditional statements. And in Petrosys, we have pre-built templates, but we also have the capability for you to make your own templates if you want to do some different sort of math or different sort of grid manipulation. And then we also talked about using grid arithmetic to solve unconformity problems by creating a subcrop grid from your unconformity surface and from your original grid. And then I hope I was able to accurately demonstrate that with the brief demo. And that is all I have. Thank you so much for listening. I've got the chat window up, and let me see if there's any questions. And if there's not, then we